Check one, check two. Alright, welcome again everyone tonight. We are continuing this For Well Thou Know analysis of Shakespearean font data using Keras. However, you might recall from last week that we built a model using about 2 features and, well, we got pretty dang good accuracy for doing that. So, tonight, we're going to make a new data set. One that hopefully isn't so simple in how you can model it. The problem isn't that, oh, the model is actually really simple. The problem is our data set, some of them, smaller fonts become very obvious identifiers as they leave most of the space blank. But I feel like that's kind of dishonest. So I don't want to do that. Just to make it clear what I feel the problem is, let's read back in the data. The old data. Yeah, there we go. And I'll show you what I mean using the nominal phrase. The titular phrase, that's what I mean. It's the title of this. Right. So last week we made a feature that was just how wide is it and how tall is it. And that did pretty dang well, and you can see why. Because this font here, font 2, is just much smaller, and I centered the data, so all this stuff on the ends here is empty. Of course, if I had the data on the left, then I'd have more space on the right. It's not as bad in the vertical direction, it looks like, honestly. Definitely is still, quote-unquote, a problem. But what I want to do is, instead of having the same number of characters for each font, I'll just fill up this space. And maybe I won't do 128 pixels wide. Maybe I'll only do half as many because I don't want to take forever to create the data set. But that's the goal anyway, to just create a data set, I think half as wide, yeah. So 64 pixels across, whatever we get. And we'll just say, oh, this is wide enough. Where does that start? Let's see. That starts at 37, right? And it ends at, yeah, 89. So yeah, totally, we can get away with this. Still calling it For Well Thou Know. It's just instead of looking at this one, we're looking at this one or this one. So that is the problem. So that's all we're going to do tonight is our goal. I have to remember to click the button in Reddit. Always forget that. There we go. I'm predicting we'll get more people from Reddit because I have not branded it as a For Well Thou Know or a Dan Does Data. I strongly suspect people see that and they say, I don't like those. So if you don't like live streaming data analysis, then yeah, I don't blame you for downvoting. But if I can get tons and tons of downvotes, there really should be a worst of, like the bottom of the list, I guess. Alright, so what I've done right here is I have this new data.py file. And right now it's just a copy of the original do_font data, or do_font.py, which you guys didn't even see. Because I made the data ahead of time because I didn't think that would be that exciting. However, we now find ourselves in a place where I need to make new data. And you know what? Since I didn't show you the first time, I'll show you this time. So I've got this Shakespearean text, or sorry, let me review what I just did. I loaded up, I got the paths to some fonts, some open source fonts that I happen to have lying around. You can use whatever if you've got OTF file types. I have 5 of them. I've got my Shakespearean data, of course, and here is where the problem is. I'm saying numchars equals this, so here's what I think I'm going to do. I'm going to change numchars to maxchars. I will display no more than this many characters. And that's because, I really shouldn't have closed this. There we go. Let's just keep this open. Keep this always available. Right, and that's because well, you know what? I can grab as much as I want. I guess I don't need a max. Oh, here I need. So I'm grabbing all the lines out of this file that have at least this many characters. Let me just say 32. So this way I ensure that I definitely have enough characters to fill out whatever I'm doing. I'm going to use a variable number of characters on each one, but it's going to be the same overall size. I already got Bill. Yeah. Numchar is not defined. Right. Max. There we go. And so, of course, phrases 2000 is now different because I've excluded more things. So maybe I'll change the name of the series. For that deep wound it gives my... That might also be a sonnet. So that for well thou know comes from a Shakespearean sonnet. Alright. I want the image size to be different. I want it to be 64 wide with 16 pixels tall. I thought it was a little taller than that. And do I dare make this 14 size? Let's do it. Yeah, let's do it. So the font size is a little bigger, the image size is a little smaller. Squish characters into, just update my comments so I don't go crazy. There we go. And data. Length fonts times length phrases. Yes, that is true. I will still have this many data points. 500,000. Whereas before I had more data points. Did I have 2 million? I don't even remember. Thought I had 250,000 in the end. Don't even remember. That's okay. And here's where I make this H5, HDF5, high density file format file using H5Py. We're going to say new font data. That's not super descriptive. We'll call it var font data because I have a variable number of characters on each line. All right, but I'm not just going to run this, right? I've got to figure out what I need to change to do this correctly. And if I get this model, if I get the font done quickly, then I'll just go move on and start doing a model. Okay, so what do we have to do here? Fonts. I just say f equals fonts of 0. That's fine. And so let's just start working through these things like one at a time. So now you get this font object if you use image font. Let me go back. I'm using Pill. You can use Pillow. That's sort of the modern iteration. I just happen to be using Pill because I had it installed and it did what I wanted to do. So that's, you can do whatever you like, whatever's easy, whatever works for you. Doesn't really matter one way or another. That's just how I'm going to create images from text and stuff in Python, especially using different fonts. So you first have to sort of instantiate your image using a particular font. Well, I guess what does image font say? Image font. No docstring. The Python imaging library. Alright, so that's just the source for the whole dang file. Never mind then. So, but that's how you sort of instantiate this font. Base, this is just where my font is located, right? Yeah, or what's the name of my font is. Dataset. This creates a dataset within the HDF5 file. So I'm not going to do that just right now. Not just yet. What's phrases 0? This is the 100th? Yeah, well. Tell you what. I equals, we're just going to say 0. P equals, I have an idea. You know what? For will thou know might not even be in phrases anymore. Right? That would be P for P in phrases if P dot starts, I need to know, starts with for will thou can. Alright. Whew, okay, it is still here. For will thou knowest to my dear. So we still have our titular phrase. That's very important. And more importantly, I need to know 0, and I want to know phrases.index. Where is this in here? 1973. Okay, so I just lost, I lost 27. 27 lines had at least 16 characters, but fewer than 32 characters. Or 32 or less. That's interesting to know. We're not analyzing how long these lines are, so that doesn't really matter. But that does mean that I want phrases 1973. B. There we go. Perfect. Got it back. So right now I'm just going through. I'm gonna run these individual lines. That's how wide it is. If I wanted to render all 32 characters, whatever, and it takes up 20 pixels tall. It claims. Now the question is, do I want to do an offset? I'm not sure that I do. These are all lines that are at least 32 characters long. I'm only putting them into 64 pixels. Let's see what happens. Let's just see what happens with the code that I have now. So I'll run the font offset, and I'll compute those offsets then. So this is sort of the new with the offset, which is not much in this case. It's not gonna, well, that height is. So you make a new image using image.new. Use image.draw to actually, it's a weird system, to actually draw the image. You say, okay, make an image of this big. The L means it's black and white or grayscale. Now we're going to actually draw to that. So draw is this thing, whereas image is, what can you do with image? All these kinds of things. Rotate, all this other fun stuff. You can do with draw. A lot of the same kind of things. Maybe no, that's not true. There's a lot fewer things in this list. Alright, but the point being, the money is, I can use draw.text, and I say, well, how big is my image? Subtract the width of whatever I'm dealing with and divide by 2. And that's sort of where I want to start. I want to center whatever the hell I'm doing, typically speaking. Here, however, we're going to find out that image size is 64. And image size minus W is negative 207. So I think this will actually work correctly. I think. Because W is 271. So that should leave. Oh, right, and it's negative 207. And it'll be divided by 2. So we'll start 100 on the left, and we'll continue all the way through. I might change this up, but let's just see what happens. So that's what we did, and then, so that's now sitting in image. If I say numpy.array of image, I get that image back. And you're looking at that and you're saying, that doesn't look like it's there. Well, if I say plot dot, what is it, show? No. Mat show, there we go, that's what I want. B. I meant image, of course. There we go. So yeah. Wow, that is way fewer characters. Let me just make that even bigger. So we put it in the middle here. And it's kind of up and kind of down. You can see, now you can really see very easily. That size 14 helps. And zoom it in a whole bunch. That the W comes kind of low on this particular font. Whereas the K is a little higher. So that's something unique to this font. Maybe the W sags low. That you wouldn't necessarily expect. Okay, but I don't actually want to start all the way on the left. I just want to start with what I have. So maybe what I want to do is not do any of this. Not do any of this stuff with the width. I think I just want to start at 0 for this. So let me make a new image, draw back into it, do my draw.text, and then let's take a look at that again. Yeah, so now I'm starting at the left. See how we're doing this vaguely correct now. So that is nice. So now, boom, it's slammed up against the left and continues on to the right. All right, so that's groovy. And it's just 4 well, and that's okay. Doesn't have to be huge. So that was actually not super complicated. Let's grab another font just to see what that looks like. Let's grab that weird font, because we did increase the size a little bit too. This was 12 and now it's 14. F equals fonts of 2. This is the one that's tiny. So let's just redo some of this stuff. Do that, do that. Let's take a look at it. And that took us like 15 minutes. That's different. Didn't expect that. Are the fonts in a different order than I was expecting? That's super. I did not expect that. Although it is like this weird block caps. W is lower here too. That's weird. Maybe W just tends to be lower, and I did not know that. Feels fonts 1. Just be pedantic here. Okay, there we go. I'm pretty sure this is the font. The ordering just isn't necessarily deterministic. So here, W is not lower, you can tell. You can still sort of see, make out for, well, thou. Maybe plotting grayscale would be helpful. .cm.gray. Yeah, that's sort of helpful, I guess. I like the heat, actually. Hot, heat, hot. Red, there we go. Hot-blooded. It's like it's all lit up at night. Cool. And I think 64 pixels wide is going to be sufficient for training purposes. Alright, let's see if I can, how long this whole thing is going to take then. I think I just want to %run new data.py, and we'll see how long that takes. Yeah, it's doing it. I believe it's doing everything correctly. Big Rocket go. Alright, so this is suggesting that my first, I've got a TQDM array here, or an iterator for each font, essentially. So if it says it's going to take 1.5 minutes, that means that it's going to take 1.5 minutes times 5, which is not great for streaming, but that's not terribly slow. So I'm a fan of that. And that should that'll shrink the size of the data set quite a bit, as it was out of control. All right, tab new var data in.py. Let me actually clear move new data.py to var data.py. There we go. And let me var data in.py. Let's open up the old data in.py as well. But I screwed up my color scheme now. So I had like a special streaming color scheme that works a little bit better with the video encoder, but it's a little goofy how it has to work. Light, no, dark, there we go. Which I should just make it my default color scheme, because it doesn't really make a big difference. Okay, so this is our old model. I want to just copy some of this stuff to the new model. Not all that stuff. Well, yeah, all that stuff, sure. There we go. We're going to say it's var font data 5. Alright, we're almost done with the first font image there. We've got 93,000 per, so we'll have, again, about 500,000 in total. So that sounds right. That sounds familiar. And for some reason, this font takes way longer. That I don't understand. Why? That one's going to take 18 minutes. So we may not be streaming for as long as we thought tonight. That's just the way things go sometimes, and that's totally okay. Let me at least manipulate this so I believe I'm reading in the data correctly. I probably should have just made a small, tiny data set. In fact, I could stop that whenever I wanted, but I'm only doing one font at a time, so I'm not going to have much in the way of labels. Alright, so our HDF5 file is set up exactly the same. So I don't need to change any of that information. One hot encoding, that's the same. I was good, I just said grab this shape or that shape. That's the same. Number of phrases is however long my data is. I do want to change one thing. This is now 1973. Good old 1973. Good times. And we'll see what this looks like here when probably next week when that all finishes. How many things we need to change? We're going to use the same seed because I want to train it the same way. We don't need to fiddle with this stuff. It's half and half. That's good. Our shape changes here. Right? Yeah, okay. Let me say n rows equals 16 and calls equals 64. Let's fix that up. So that at least we'll be ready. We can focus on the modeling rather than the fiddling, as you might call it. And rows and calls. Oh, and calls, there we go. All this caret stuff, that's going to stay the same. We'll lead off with the same model, that's fine. Batch size can stay the same, that's not, that 128 is not reflected in the original model. Num_param, this is something I screwed up. It's not 2048, because 2048 was the 128 times 16, I believe, which is the same as saying 2 to the 7 times 2 to the 4, which equals 2 to the 11. And I happen to remember that 2 to the 10 is 1024, and twice as much as 2048. All being sold, this is going to be 1024. Right, because I've cut one dimension in half, so therefore it must be half as big. 1024 versus 2048. All right, Sutter stuff, this is the same. That was my whole model there? Wow. Build as simple a model as possible. Okay, I don't think I'm doing anything too fancy here. 3 parameter. I had a 3 parameter model? Didn't even realize. All right, so we should be able to use this modeling file to get a start on this. And again, the goal is just to have a simple model that I'm envisioning will not do very well if it's just a pure like logistic regression or even a simple densely connected neural network. I suspect with a convolutional model you can start to get a pretty good set of results. But what I'm curious about actually is if you can get a good set of results using a recurrent type neural network. I want to look at those. Now I've nuked my images. Oh well. If you look at those fonts, if you look at the images of those fonts, and you look at sort of a few columns at a time, enough to maybe be a character, say, you can slowly build up information about what font it looks like, rather than having a model on the entire image that's 64 pixels by 16 pixels. Because like that's a lot of parameters to train. Even if you're doing a convolutional net, even if you do a lot of convolution and pooling layers, you're going to end up at the end with a fair number of parameters. I'm wondering if you can come up with a much smaller number of parameters by doing this recurrent thing. So you look at a few set of columns, compute something on those, and then you look at the next set of columns, and you also have this history behind you. It might not even be necessarily a neural network per se, but that's another way to maybe capture some of the features. And in this case, we're using the structure of the data in that we know that it's characters, text characters. So a few columns at a time, however many columns it is, that's like one character. So we expect something significant to go in line with that. And that's really what the name of the game is. Can you use your knowledge of the structure of your data set and your problem set in order to assist your modeling? Because otherwise you're just using a black box. And nobody likes that. Well, some people like that. I don't like that. I have a desperate obsession with understanding what the heck my model is doing. That's half the reason I do these videos, because I know if I'm building the model here and I'm trying to explain it, that means that I'm forced to better understand it. Okay, because this is going to take at least another 10 minutes for this font. I don't know why some fonts take longer than others. That's a good mystery. And there's 3 more fonts after this, and I suspect they'll also take their good sweet time. It might be that this might be the nature of the data file, that I made the data file and then I made the data file that much larger, and so it's doing something silly. That it's doing that. But anyway, because I did all that, I'm going to cut the video short. There's no need to drag it out just to wait for this progress bar to fill up. You guys can do that at home. I will git commit these new changes and you can check that out. You can follow along at home. That's all I got for tonight. I didn't see any questions from the audience, so we're going to call that good. Always remember, stay safe in the data mines.